You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. The purpose of this episode is to explore the essential characteristics that define cloud computing and the security implications that follow from them. These traits on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service are what distinguish cloud from traditional hosting. They enable agility, scalability, and cost efficiency, but they also introduce unique risks. Understanding these characteristics is fundamental to both CCSP exam preparation and practical governance. They affect everything from how trust boundaries shift to how compliance is documented. In practice, secure cloud adoption depends on designing controls that account for the very traits that make cloud appealing. For learners, this session translates abstract definitions into real-world considerations, showing why each characteristic demands disciplined oversight. On-demand self-service means that customers can provision resources such as servers, storage, or databases without human provider intervention. While this accelerates agility, it also introduces risk if governance is weak. Developers may deploy services rapidly, bypassing security review. Shadow IT often arises when teams create resources outside approved processes. For exam purposes, on-demand self-service underscores the importance of policies, identity governance, and automated controls that prevent misuse. In professional settings, organizations use guardrails such as service catalogs and policy enforcement to balance flexibility with oversight, ensuring that speed does not compromise compliance. Broad network access describes how cloud services are delivered over standard protocols and accessible from diverse devices. This universal accessibility supports remote work and global operations, but it also expands the attack surface. Every endpoint becomes a potential gateway to sensitive data. Secure design requires encryption in transit, strong authentication, and continuous monitoring of access. For CCSP learners, exam questions often use broad network access to highlight the need for controls at the network and identity layers, reminding you that cloud is not isolated. It is inherently exposed. Resource pooling underpins multi-tenancy, where providers allocate resources dynamically among consumers. From the customer's perspective, resources are abstracted from their physical location, offering efficiency and elasticity. However, pooling also raises concerns about data leakage, noisy neighbor effects, and jurisdictional uncertainty. Providers address these risks with logical isolation, dedicated encryption, and compliance certifications. Customers must reinforce this with careful configuration and due diligence in contract review. Exam questions that reference resource pooling often test whether you can connect multi-tenancy with the need for strong isolation and audit evidence. Rapid elasticity provides the illusion of unlimited capacity. Applications can scale up during demand spikes and contract afterward, optimizing both performance and cost. From a security perspective, elasticity introduces dynamic trust boundaries. New instances appear and vanish, requiring automated controls to enforce consistent baselines. Identity permissions, logging, and monitoring must keep pace with the rapid lifecycle of resources. For CCSP preparation, elasticity scenarios emphasize that manual controls cannot scale. You must rely on automation and policy-driven enforcement. Measured service introduces transparency by metering usage. Consumers can see exactly what resources were consumed, enabling chargeback and accountability. From a security standpoint, metering supports anomaly detection. Sudden spikes may indicate abuse, misconfiguration, or attack. For exam readiness, measured service highlights the dual role of metering financial governance and operational security. In practice, organizations integrate billing data into monitoring pipelines to spot unexpected consumption patterns, turning economic visibility into a layer of defense. Multi-tenancy describes multiple customers sharing the same infrastructure with logical separation. This is both a benefit and a risk. Providers implement hypervisors, containers, and encryption to ensure tenants cannot interfere with one another. Customers must validate that these assurances meet compliance needs, often through society reports or independent audits. Exam items often use multi-tenancy to test whether you understand that isolation is provider-managed but customer-validated. In real life, multi-tenancy demands contractual assurances and careful monitoring to ensure that logical boundaries remain intact. Abstraction layers decouple applications from hardware through virtualization and managed services. This allows portability and scalability, but also obscures visibility. Customers must trust providers for operations below their layer of control, reinforcing the importance of shared responsibility. Exam questions that reference abstraction emphasize that while convenience increases, accountability for how abstractions are used still rests with the customer. Self-service portals and APIs expose the management surfaces of cloud. These enable automation, orchestration, and programmatic control, but they also become high-value attack targets. Securing them with multi-factor authentication, role-based access, and rate limiting is critical. For CCSP learners, API exposure is a frequent exam theme, reflecting its centrality in modern cloud operations. Metering and chargeback models bring accountability within organizations. By aligning usage with cost, they prevent resource sprawl and encourage efficiency. From a governance perspective, chargeback reinforces responsibility at the business unit level, ensuring that costs, and by extension risks, are visible. Exam questions often test whether you can link measured service to governance practices like chargeback. Elastic scaling patterns include horizontal replication, stateless design, and queue-based buffering. Horizontal scaling adds instances, stateless applications allow them to be ephemeral, and queues absorb variable demand. Each pattern supports resilience but requires controls, such as encryption of replicated data and monitoring of dynamic endpoints. For the CCSP, scaling patterns highlight the need to secure not just static systems, but constantly shifting architectures. Capacity planning adapts these patterns into practice. Forecasting demand, setting thresholds, and maintaining controlled headroom ensure elasticity works without overspending. Security intersects here. Over-provisioned resources may sit idle and vulnerable, while under-provisioned resources may fail under attack. Exam scenarios may test whether you recognize that capacity planning is both a performance and a security concern. Resiliency constructs like regions, availability zones, and fault domains contain failures. By distributing workloads, organizations prevent single points of failure. These constructs intersect with compliance. Regional choices affect residency obligations. Exam questions often test whether you can apply resiliency constructs appropriately to align with both availability and legal requirements. Ephemeral infrastructure is the natural result of elasticity. Short-lived instances are provisioned, replaced, and destroyed automatically. This reduces configuration drift, but requires new approaches to logging, monitoring, and backup. For CCSP learners, ephemeral resources emphasize automation and immutability, since manual processes cannot keep pace with short life cycles. Consistency models balance correctness with performance. Strong consistency ensures all reads reflect the latest write, while eventual consistency allows temporary divergence for scalability. Each model has security implications. Inconsistent reads may confuse monitoring or create unexpected states. On the exam, consistency questions often test whether you can link the right model to the right use case. Finally, elasticity itself creates security challenges. Dynamic trust boundaries, constantly changing inventories, and short-lived access requirements all strain traditional controls. Time-bounded credentials, automated monitoring, and rapid enforcement of baselines become essential. For exam purposes, these scenarios highlight why cloud security demands automation. Without it, elasticity undermines consistency and control. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Identity-driven automation is one of the most effective ways to bring order to elastic environments. By tying automation to roles and policies rather than static credentials, organizations ensure that every action is executed with least privilege. Time-limited credentials further reduce risk by ensuring that access expires as resources come and go. In environments where instances may live only minutes or hours, permanent credentials create long-lived vulnerabilities. On the exam, identity-driven automation appears in scenarios about how to enforce security consistently in highly dynamic environments. In practice, it is the foundation for scaling governance as rapidly as infrastructure. Quota and limit management prevent overconsumption and abuse of cloud services. Without quotas, a misconfigured script or malicious actor could spin up thousands of instances, leading to a denial-of-wallet event where costs skyrocket. Providers and customers must work together to define thresholds, enforce controls, and monitor for anomalies. Exam questions may highlight quota management as a financial and operational safeguard that doubles as a security control. This reinforces the point that in cloud, cost and security are inseparable. The noisy neighbor effect illustrates the risks of multi-tenancy. When multiple tenants share the same physical infrastructure, one tenant's workload may consume disproportionate resources, degrading performance for others. Worse, misconfigured isolation could expose data. Providers mitigate this with hypervisor controls, monitoring, and capacity safeguards. Customers must validate assurances through compliance artifacts and monitoring. On the exam, noisy neighbor scenarios remind you that isolation is central to cloud trust and must be reinforced through both provider guarantees and consumer diligence. Tagging and metadata standards enable governance at scale. By attaching metadata to resources such as owner, environment, or sensitivity, organizations can enforce policies automatically. Tags drive cost allocation, monitoring, and security controls. For example, all resources tagged as production might require encryption and logging. Exam questions about tagging highlight the importance of structured metadata in managing dynamic, elastic environments where manual tracking is impossible. Immutable infrastructure reduces configuration drift by treating servers as disposable. Instead of patching or reconfiguring instances, organizations replace them with fresh, hardened builds. This speeds recovery and ensures consistency. Exam scenarios may test whether you recognize that immutable designs align with cloud-native principles, eliminating snowflake servers that resist automation. In practice, immutability supports both resilience and compliance, since every build is consistent with baseline standards. Event-driven operations coordinate scaling, remediation, and compliance checks. Policy triggers, such as CPU spikes, failed health checks, or security findings, automatically launch corrective actions. This shifts operations from reactive to proactive, embedding governance into the fabric of the environment. Exam questions about event-driven models emphasize that automation is not only a convenience, but a necessity for secure elasticity. Rate limiting and throttling protect shared services from abuse. They restrict how many requests an API or service can handle in a given period, preventing overload from legitimate spikes or malicious floods. For CCSP learners, exam items may highlight throttling as a control that ensures fair use, protects reliability, and reduces exposure to denial of service conditions. Web application firewalls, or WAFs, protect elastic, internet-facing applications from injection, cross-site scripting, and other application layer attacks. Because cloud services are accessible globally, WAFs become essential shields. In exam contexts, WAFs often appear as the correct response to scenarios involving publicly exposed applications. Telemetry design is critical in elastic and multi-tenant systems. Metrics, logs, and traces must capture not only performance, but also how resources scale up and down. Without this telemetry, forensic analysis becomes impossible when ephemeral resources disappear. On the exam, telemetry questions emphasize the need for consistent, centralized monitoring that accounts for elasticity. Cost optimization aligns financial discipline with security. Right-sizing instances, Using reserved capacity and configuring auto-scaling policies are not only cost-saving techniques but also governance practices. Over-provisioned resources invite waste and potential exposure. Under-provisioned resources risk availability. Exam items may frame cost optimization as both an operational and a security imperative. Service level agreements, or SLAs, define availability targets, error budgets, and remedies. In elastic systems, SLAs must reflect the dynamic nature of scaling, ensuring customers understand expectations for uptime and reliability. For the exam, SLA questions often emphasize aligning contracts with resilience and monitoring practices. Backup and recovery practices must adapt to ephemeral resources. While virtual machines may be short-lived, data persists and must be protected with snapshots, replication, and external storage. Recovery focuses on data-centric protection rather than individual instance preservation. Exam items often test whether you recognize that ephemeral workloads require a shift in strategy. Rebuild infrastructure, but protect data continuously. Compliance evidence generation becomes more complex in multi-tenant platforms. Customers rely on provider attestations but must also generate their own evidence for configurations, access controls, and monitoring. This dual responsibility ensures regulators and auditors can see that both sides of the shared responsibility model are being met. Exam questions highlight compliance as a shared duty that requires structured evidence. Anti-patterns in cloud include manual provisioning, persistent pets that resist automation, and untagged resources. These practices undermine elasticity, governance, and efficiency. They persist when organizations fail to embrace automation or enforce standards. On the exam, anti-pattern questions often test whether you can identify practices that contradict cloud principles. In summary, cloud characteristics enable agility, scalability, and resilience, but they demand disciplined controls to prevent risk. On-demand self-service, elasticity, and multi-tenancy are powerful enablers, yet they shift accountability toward automation, identity, and governance. For the CCSP, exam relevance lies in mapping characteristics to control requirements and operational realities. In practice, mastering these traits ensures that organizations enjoy the benefits of cloud without compromising security, reliability, or compliance. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.